Let's take a look at leaving the unit circle. Leaving the unit circle is the concept of the fact that we don't always have a hypotenuse of 1. We're not always doing triangles that always have this hypotenuse number being 1. As soon as we don't have a hypotenuse of 1 anymore, we're not on this unit circle where we know all the numbers. So an example of that would be something like this question, where it says find the 6 trig functions or trig ratios for something like -2, 4. Well, if I'm going to do that, if I'm going to try to find the trig ratios for -2, 4, the key to this strategy is to do -2, 4 and plot that point. So -2 would be here, 4 would be here. Those become the side lengths of my triangle. I connect the hypotenuse automatically to that point, and I call this angle theta, which is that like O with a line through the middle. And this is the angle that I'm using then. Then to find my hypotenuse, it's a squared plus b squared equals c squared, which would give me 16 plus 4 is 20. So it's the square root of 20. Well, the square root of 20 you can rewrite as 2 times the square root of 5, because 20 is 4 times 5, and each of those would be attempted square root, which this would be 2, this would be the square root of 5. That's how you make that change. So with that being said, then I just calculate all my ratios. Well, sine would be opposite over hypotenuse, so that's going to be 4 over 2 times the square root of 5. Now, if those numbers didn't reduce, or if we didn't have the square root down here, we'd be done. But we're not. So that creates a little bit of an issue. So I've got to rewrite that. So one of the first things you do is 4 and 2 both divide by 2. So that would be 2. This would be 1, so I'm not going to write it. So it's 2 over the square root of 5. Then I've got to rationalize by the square root of 5 times the square root of 5, and I get 2 times the square root of 5 over 5, and that would be the sine answer for theta. Cosine is adjacent. That's -2. This is the part that touches. This is on the coastline, cosine, over hypotenuse. So -2 over 2 times the square root of 5, and I have to simplify that. -2 divided by 2 is -1 over the square root of 5, and I would be done, but I have a radical in the denominator, so I must multiply by the square root of 5 over the square root of 5, which gives me negative times the square root of 5 over 5, and that's my cosine. Tangent is sine over cosine, or opposite over adjacent. So I'm going to do opposite over adjacent, and I end up getting positive 4 over -2. And then when I do that, I end up getting -2. The next one is cosecant. Cosecant is 1 over the sine. So here is what I had this sine equal to, and then I had to mess with it and rationalize and all that. So if I just flip that over, it'd be the square root of 5 over 2, and that is my answer. Cosecant is 1 over the cosine. Here is what I had the cosine equal to before I had to rationalize. So it's just negative square root of 5 over 1, but I'm just going to leave it as negative square root of 5. Cotangent is cosine over the sine. That would be this over that, or it's adjacent over opposite, so that would be -2 over 4, or just this flipped over. So that gives me -1/2, and that is my cotangent. So you have to make calculations with these triangles, and then you have to know what all of these are calling for, and then set those up, and sometimes you have to rationalize the denominator. The other way that these can look is if you're given 2 facts. If I'm given 2 facts, that the tangent is 3/4, well, I can fill that in over here. The tangent has to be 3/4, and then if the second clue tells me that the sine is less than 0, well, that means I have to be down here somewhere. I have to have a negative sign. I have to drop, because the sine rise would actually be less than 0, and the sine is less than 0 down here. Well, if my tangent is 3/4, if I go over 3 and up 4, that doesn't work because I need opposite over adjacent to be 3/4. Well, if I did 4/3 like this, that would be opposite over adjacent. That's 4/3. So I'd have to go like this, 3 and 4 like that. So then it's opposite. Oh, that's 3/4. That works. The problem with this location is that the sign is positive. This is going up in a positive sign direction. So could I just flip it down and make this -3? Well, no, because then I've got -3 over 4, which is not positive. So I actually need this one. This one's the correct answer. I'd have to go back 3 and down 4, right? So that, or excuse me, back 4 and down 3. Whoops. So then that gives me opposite, which is -3, adjacent, which is -4, and that reduces to a positive 3/4. Then this is where my hypotenuse is, this is where my angle is, and then a squared plus b squared equals c squared, and for this would be 4 squared is 16, 9 is 25, square root of 25 is 5. My hypotenuse is 5. And then I just go through opposite over hypotenuse, so this is negative 3/5. Adjacent over hypotenuse, this is negative 4/5. Cosecant is the sine flipped over, so that's negative 5/3. Secant is the cosine flipped over, so that's negative 5/4. And cotangent is this flipped over, so that's 4/3.